Okay. Well, I don't think. How many people are in attendance down at the coast? Because I can only see 3 of you.
Can they see the screen? There's only 3 of us.
Okay. Okay, so 2 are not in attendance. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20. Actually, okay, everybody's up here in Hattiesburg, but okay, so the 2 from the coast are not there. Will not see have missed out on the first part of the tutorial. Sorry about that. Okay. So, all right, but at least we have the rest of it when I'm editing my M file. Okay, so again, please feel free to remind me at the start of class that I need to start recording because I'm losing it. Okay, so I create a random number. In the interval -1 to 1. And then we go ahead and print it out. Now, a construct I have not yet discussed, but I will now, is an if statement. So I'm going to check if x is positive using appropriate relational operator. And if it is, I'm going to display the statement x is positive. Okay. Now, yes?
Does it read that rand1 as a scalar or just a 1-by-1?
So it's a MATLAB for storage purposes. Pretty much everything in MATLAB is an array. So yeah, an array with 1 element, unfortunately. It may possibly optimize and treat it as a plain old double. I would hope so, anyway. Now, one thing I want to point out before I continue is, if you look right here at the upper right corner of the editor, there's going to be a color code, red, orange, or green. Red means you have syntax errors in this file. And I do because I have an if statement that I've started and not yet finished. So this is syntactically incomplete and therefore incorrect. The red dash down here indicates where it's the spotted problem. Notice it's you may not be able to see, but there's a red line under the if that again is pointing out the spot of a problem. If this is orange, there are not errors, but there are warnings, and you can hover over them to find out what the warning is. We may see that later. And if it's green, that means you're good to go. Now, your code may still be totally wrong, but there are no syntax errors or warnings. Okay, so then if x is negative, I want to display the appropriate message in. So I start typing else. Notice my cursor was here. Then I started typing else here. As soon as I finished the word else, it moved it to the left. So MATLAB's editor has automatic indentation. Please take advantage of it. Because sometimes I get code from students where it's not indented properly. It's a mess to read, and it's just painful. And I'll show you how to auto-indent in a moment. Notice when I hit enter, the cursor jumped down here so I can continue typing. So it's doing its best to figure out how things should be indented. And indentation is optional in MATLAB like in C and C++. But it's a good idea to practice it. Okay, sorry, I forgot the rest of this line. Else if x is negative, display the message x is negative. And then else, what's the only possibility left? And I will display that. Okay. And then to conclude the if statement, notice here it's still red because I'm not finished. I'll type end. So you have to explicitly end an if statement. And now it's green because all the syntax errors are gone and there are no warnings. Okay. So that's what this code does. It gives me a verbal indication of the sign of x. It's telling me it's positive, negative, or 0. So now I'll go ahead and save this file. So before I run it, I'm going to point out the how if statements are structured. So you begin with an if, and you have a conditional expression of some kind, something that evaluates to true or false. a numeric expression is allowed, it would just consider it false if it's exactly equal to 0, or true otherwise. If you have more conditions, that's else if, and it's one word. Different languages have different rules for this idea of additional Boolean conditions. So this is how it is in MATLAB. It's else if mashed into one word. After all possibilities are exhausted, you have a default case. Then you just have a plain old else, and then don't forget an end to conclude your if statement. Okay. All right. So questions about this before I run it? All right. Now, as far as running it, there's a couple ways I can do that. I can go back to the prompt and just type the name without the .m. So that's how MATLAB understands which M files to refer to, just by the name without the extension. So I go ahead and do that, and it picks this random number and tells me that it's negative. Now, the other way I could run it is here. We have a green arrow up here to run. That's good for files like this that are scripts. In other words, sequences of commands that you could also type into prompt. There are also functions, function M files, bless you, that also have a .m extension. And so in those cases, you should not use run for that because you have to supply input parameters. And this green run button doesn't let you do that. So only use the run button for scripts, not for functions that require arguments. Okay. Or if you forget this, you can just learn that the hard way, as pretty much all my students do. Okay. Now, and I could go ahead and run this again. Notice I could scroll back through my history. I didn't do this last time. Using arrow keys to scroll through. And just run. Oh, did I do something? Oh, I accidentally typed a character in there. Let's get rid of that. Okay. Yeah, so I can just run this and keep getting whatever random numbers and their signs. Okay. All right. So questions about running scripts or if statements? Alrighty. Now, okay. Now I have another file. This one I've already created. It would take too long to type in here. Okay. So this is also a script file. It's not a function. So, yeah. So I'm going to give you a tour of this before I run it. So the purpose of this script, which is called entermonthyear.m, so it will ask the user to specify a month and a year, a 4-digit year, and it will print out how many days are in that month and that year. So it's going to take leap years into account. So there's a lot of functionality that we're going to see here. And I have a commentary. So all these files that I use in the tutorial today, I will post on the site afterwards. Or tomorrow when I post what video I have. Okay, so I have here the input command. So that's used to prompt the user for something. So the input function, I specify as an argument a prompt. So that's a string. Notice it's in single quotes. So I prompt them for a month. So whatever the user types in, they'll type something in and hit enter. and that'll be returned in the variable month. And then same thing for entering a 4-digit year. Okay. So then I have two numbers, month and year, that are user supplied. Now I want to be able to print out a nice message. Like suppose they type in 5 for May, and then 1996. I want to be able to print out the name of a month they supplied, but they gave me a number. So what I'm doing here is I'm creating a matrix that has characters in it. So that's something you can do. So here's a matrix, but each row of a matrix is a character string. Notice the semicolons that separate rows, and they have the names of all the months. Now, notice that almost all of these have spaces at the end of a name. And the reason why is, since it's a matrix of characters, each one has to have the same length. September is the longest month name, 9 letters. So that's the only one that doesn't have spaces at the end. So this is a matrix that has, you think it's a matrix of characters that has 12 rows and 9 columns. Okay. So now that I have my matrix of month names, what I can do is, MATLAB uses one-based indexing. So the number of the user types, I can use as an index into this array to get the month name. So if they type 5 for May, then this expression, accessing row 5 and all the columns, will give me a string in month name that has May in it and a bunch of trailing spaces. So basically this matrix is letting me map the number they type in to a month name. Now I have all those annoying spaces at the end. I want to remove them. And MATLAB has a convenient function for that, dblank. So the string that's passed in here will be like the month name followed by all these spaces. So it'll remove those trailing blanks. Now I have a character string that's just the name of a month without those spaces. So now I need to figure out how many days that month has. Now February is a special case. So I have an if statement. And just really the purpose of this script is to illustrate another if statement. So I check, is a month equal to 2 for February? So I need to find out if a year is divisible by 4. Is it a leap year? So this function, rem, short for remainder, is useful for that. So what it'll do is it'll divide the first argument by the second, find a remainder, and that's what is returned. So if a remainder after dividing a year by 4 is 0, I know it's a leap year. So I'll have 29 days. Else, so if this turned out to be false, because there is a non-zero remainder, the year is not divisible by 4, then I set the days to 28. So this if statement within an if statement handles the case of February. Now, after this is taken care of, if the month was not February, I skip down to here, and now I check these conditions. Is a month equal to one of the 4 months that has only 30 days? So I check, is it April, June, September, or November? In that case, I set days equal to 30. Anything, if none of these apply, all the conditions up to this point turn out to be false, then I know that I have 31 days in a month. So days is going to have a value no matter what because I have this else statement. So even if all the conditions that are evaluated don't apply, we have this. And I point that out because you can have a situation where you're using an if statement to set the value of a variable, and you have, if this, do this, if this, do this. If you don't have an else case, the variable will not have a value at all. And if you try to access it later, there'll be an error. So beware of that. Make sure that if you're going to access a certain variable, make sure that whatever code prior to it actually gives it a value. So at the end of this if statement, the variable days has the correct number of days in that month that the user supplied. So now I want to print that out. And I use disp for that. But what I want to do is actually construct a string that has a nice readable message. So notice everything I have here highlighted is enclosed in square brackets. So I'm making a string variable, and so the square brackets indicate where the string begins and ends. So first I have a name of a month that from my array from before. Then in single quotes, I have a comma. And then I have a year, but a year is a number, and I need character strings. So MATLAB has a function, num2string. So it converts a number to a string to fill in here. And then the word has. And then I do the same thing with the days. And then I tack on this last text. And now I have my message that's going to be printed out. So if I go ahead and run this, enter month year, again without the extension. So I'll put in September 1969, that's the month I was born. Yeah, just missed the moon landing. And that month has 30 days. Yeah. So it took the month name from my array, the year and the number of days converted to strings, and then filled in the text around it to print this statement. All right. So if I go back to the code, does anyone have any questions about what this code did? Yes.
What would have happened if you didn't do the num to string?
Oh, if I just put in year here. Sorry, what?
What would have happened?
Oh, there would have been an error.
Okay.
Yeah. Yeah, MATLAB is, well, I guess moderately permissive as programming languages go. But yeah, mismatched types like that, it's not going to like that. Yes.
Do you have mod 100 condition in there? It's not leap year, it's mod 100.
Okay.
I just missed that.
2000 was a leap year. Okay. Yeah. So that additional condition, I did not have. Yeah, I didn't account for that. Yeah. Yes.
Could you explain why you use spaces after the month name?
Oh, here.
Yes.
Because if I just, otherwise that would also be an error. I'm making a matrix of character strings. Every row in a matrix has to have the same number of elements. So it was to make. So since all the month names, the longest month name is 9 characters, I had to make sure each row of this matrix had 9 characters. So it's for uniformity of the rows. Yeah, because otherwise that would throw an error also. Other questions? Yeah, because you're supposed to be like 365.25 seconds or days, and
Yeah, it's
Yeah.
365.2501.
yeah, something like that. Oh, okay, yeah. So then, yeah. Thanks. Should have assigned that as a problem. Oh, well, actually, I do have problems in this assignment where you are doing things with this script, like to make it do over things. So
I think every rotation of the Earth is a little bit less than 24 hours, 24 hours.
yeah.
So
So
you
yeah.
get that as a
Yeah. Yeah. Now it's too lazy to look that up and put it in here, but
Yeah.
I think the script is enough to digest as it is.
Yeah.
Yeah. Hey,
Right.
you ever questions? Alrighty. Okay. So I need to get rid of the pages I've already been through so I don't accidentally pick them up again. Okay. All right. Yeah, two of the problems in the assignment. One is day in year. So if you have a given day within the year, and have all the days numbered from 1 to 365 or 366 if it's a leap year, what number day is it? So, for example, February 1st would be day number 32. because of the 31 days of January. One problem is figure that out. And then the other problem, which is definitely the hardest in the whole set, and I think not too many people got last time around, but give it a shot. I do give partial credit. I'm actually fairly generous with it, more than most. Is given a date, including a year, that identify or print out a message indicating which day of a week it was. So you're given a day of a week for a particular date, like I think it was like December 31st, 1999, as a reference point. So we would pinpoint what day of a week a day was. So for instance, if you go ahead and type into the script the date, September 21st, 2019, it'll tell you that it was a Saturday. And yes, I'm happy that my birthday's on a Saturday this year because I was that little kid who was annoyed that I didn't get school off for my birthday. So, okay. So those are a couple problems you can look forward to. Okay. All right. Next. Hello. Okay. So next programming construct that anyone with programming experience would be familiar with, for loops for iteration. So I'm going to open up another script that I've typed in previously that will illustrate the use of for loops. Okay, so this script is called compute mean. So what this script does, computation-wise, it generates a random vector of 10 numbers, and it just computes their mean. Now, MATLAB has a function that computes the mean. If I have a vector x, I can just do mean of x, and it'll give me the mean. But I'm not using that here because I want to illustrate for loops, not those kind of functions. Okay, so I generate a random vector, and then I go ahead and display it. And then what I want to do is sum up all the elements. Now, MATLAB actually has a function that sums all the elements of a vector. You can just do sum of x, which we'll see later. But again, I want to illustrate loops. So I want to have a variable m that is a sum of all the elements in the vector. So I initially set m equal to 0, and now I'm going to iterate over all the elements. So I have this loop that's going to do that. So this loop is going to add on each element of a vector. So x parentheses I is the ith element of a vector. So this loop, so for is the start of a loop, and then I have my expression here for assigning values to a loop variable. So my loop variable is I, and I'm going to assign it values 1 through 10. So m will add on x1, x2, x3, and so forth up to x10. And then just like an if statement, you need an end to mark the end of a loop. Now, what's weird about MATLAB for loops is, now for loops in general, you will generally, most of the time, you'll have some variable that's meant to count all the iterations, and that's I in this case. And in many programming languages, you indicate what value it's starting with and what value it'll end at, and so forth. And maybe how many, what kind of step it'll take. Will it increase by 1 or 2 or whatever? Now, what MATLAB does is this expression here, 1:10, that is a row vector of the numbers from 1 to 10. What MATLAB does is whatever expression you give here, whether it's a vector like this or a matrix, MATLAB for loops go through this expression and they take each column. So I is assigned each column of whatever expression you have on the right side of E equals. Now in this case, it's just a row vector, so whatever it assigns is going to be a number. But I've actually carried out for loops where I have like A equals, and I have a matrix over here, and I know that my variable will be assigned each the first column, second column, third column. And sometimes that's quite convenient. But what I'm showing you here is a typical usage of loop variables.
It makes a new vector every time you have to make a
Oh, no, this will only be allocated once. Okay, but like for instance, if I have multiple loops with this vector, I would hope it would be smart enough to optimize that, but I can't really say. Okay, so whatever value is assigned each time from a loop, that is the value it has throughout the body of a loop. So first time through I is 1, then 2, and so forth. Now, what you should be careful about, and this is true regardless of language, whatever value you have here that's being assigned to something new every time, don't change it in the loop. Keep track of your variable names. So I've seen students make a mistake where they have a loop, like for I equals 1 to 10, and then they're using I, same letter, for some other purpose elsewhere in the loop, and they'll assign its value, and that throws off the loop. So don't do that. Now once a loop is concluded, M comes out of a loop equal to the sum of all the elements of X, but we want the mean. So we have to divide by the number of elements, which is 10, so we divide by 10, and then we go ahead and display the mean. So I can go ahead and run this at the prompt. Okay, so it just shows me the vector x and then computes the mean. Not very interesting. Okay, so any questions about how a for loop is written? We'll see other examples, but questions about this one? All right. So when you figure out how many times is your loop supposed to run based on whatever the task is, what you can always do is have a variable that counts from 1 to however many times it's supposed to run. And then I will have that value inside the loop. So I have a one of the problems in the assignment is to modify this to add another loop that would compute the variance as opposed to the mean. Okay. Here's another script. So its job is to, again, work with a random vector of 10 elements, find the maximum of them. So just like before, generates the vector, random numbers, displays it. So now, how do we find a maximum? What we can do is keep going through the vector, inspecting every element. If the new element we're looking at is greater than, strictly greater than, the maximum we have found so far, then we update. So in other words, we're keeping track of a maximum we've seen so far. We keep updating it as we go. So xmax is my variable that refers to the maximum element of x. So initially, it's the first one, because that's all I've inspected so far. Now I look at the rest of them. So I goes from 2 to 10. Why not 1 to 10? Yeah, we've already looked at the first one. We just need to look at the rest of them. So I look at each element, x2, x3, and so on. So each time, if it's greater than the maximum I've found so far, update that. So xmax is the maximum of x1 up to I. So that means that when I is equal to 10, I've looked at everything. So xmax comes out of its loop being equal to the largest element. Okay. All right. So here we have an instance of a for loop whose body consists of an if statement. So this if statement is evaluated every time through a for loop with the new value of I. So questions about this one? find max. Okay. Now, here's another script that involves for loops. This one far more mathematical. Also far longer, sorry. Okay, the job of this script generates a random 40 by 40 matrix and prints it out. And then it performs Gaussian elimination, as you learned about in the first linear algebra course. And once it performs Gaussian elimination, it will print out the updated matrix. So Gaussian elimination performs row operations to zero out all entries of a matrix that are below the main diagonal. So the result is called an upper triangular matrix, also said to be in row echelon form. So hopefully, well, I'm not going to really deal with those terms much in this class, but hopefully that rings a bell. Okay. So I set my size of a matrix, m by n, generate this random matrix, and then print it out, which would be generate a lot of output. And then we have nested for loops, because the outermost loop works on the columns. So we're going to start by eliminating entries in the first column, then move to the second, third, and so forth, all the way up to the last. But we don't do the last column because there's no entries to eliminate. There are no entries below the diagonal in the last column. So we go through columns 1 to n minus 1. This loop, its job is to iterate through all the rows below the main diagonal. Now, in column J, the diagonal entry is in row J, so it's the JJ entry. So we want to go through all the rows below that. So I starts at J plus 1. So here I'm taking a current value of J and using that as my starting index for I. And then I go all the way down to the bottom. So this will go through that column, column J, and perform a row operation. Now I actually have the code for the row operation written in two different ways, but only one of them is used at a time. I'm going to briefly uncomment this. This is the, oh, that comma shouldn't be there. A comma is a sign of old MATLAB code. A comma used to be required like 20 years ago. Okay. Now, here's how, so the job of this loop is to go through elements of row I, starting from column J all the way to the end. And then perform this operation. This is part of a row operation, which I won't get into the linear algebra of this here, but what we're doing is we're taking each element, subtracting from itself this multiplier times ajk. Now, so this is how for loop would normally be written to do this. But it's not actually necessary to write it this way as a standard for loop. This code down here does the exact same thing as this for loop. Because what I'm doing is I'm looking at row I, columns J through N, which are the same columns as referenced here. So this portion of this row is equal to itself minus some multiplier times the same elements of row J. So now I only want to have one of these actually active at a time, but so that's why I have one commented out and the other not. But so expressions like these can be used to write what you think of it as an implicit for loop, or you can use an explicit one. So in terms of correctness, it doesn't matter. One may be more efficient than the other, but I think they've got to a point where it's about the same. Now the reason why this works, though, is that each one of these operations in this loop does not affect the other ones. Like they could be done in parallel if you had the computer for it. So that's why it can be written this way. If I have a situation where what I do in this one iteration of this loop actually affects what happens in another iteration of the same loop, then I could not do this. So That's one thing to keep in mind for more complex tasks. Okay, so there are multiple ways to write these loops. Like this one would certainly be more compact. Okay, and then we print a matrix afterwards. Is there a question? All right. Now, what I'm going to do is this script's going to generate a lot of output, and I don't want it to just fly by in the screen. So what I'm going to do before I run it, I'm going to type more on. Those of you who are familiar with the Unix, like the Unix command more, that pages the output, so you can actually read through it as it flies by. So that's similar thing here. So I'm going to type in Gauss-Elim. So it starts printing out the matrix. So all these columns, starting with the first 4. So there's a lot of these to get through. So I'll just quickly page through the printing of a matrix. So I just hit the space bar to scroll through the matrix. This is a matrix, the original matrix, before elimination happens. And I got 40 columns to go through. All right, these are the last ones. After elimination, it's printing out the matrix again. But notice all the entries below the diagonal are 0. That's what Gaussian elimination does. Notice 0 is represented in different ways. Here, like sometimes we just have plain old 0 by itself. Other times we have 0.000. That's because of rounding error. So these numbers are very small, they're just not exactly 0 in the floating point system. And we even have -0. So in the floating point number system, you can have 0 and -0. Same value, but they actually are like internally stored differently. And when we get into chapter 2 on computer arithmetic, I'll cover all of that.
Does it stop computation when it gets to that, or
No, it's just stopping the output. So the computation's already happened.
yeah, I mean, when it's doing it, does it stop at the
Well, okay, this particular script, okay. In this case, there's no, I have printing, computation, printing, so it's nicely segmented like that. But you must be probably thinking of a script where I say you have a loop going. There's output in a loop between each computation. So in that case, I think it's the same as a pause, because a pause command stops computation. I'm trying to think of a situation where this would apply, where it's like something to be concerned about. Like if you have, because I have had cases where, like, since output generates a lot of overhead, if I have a computation that I run twice, the first time doesn't generate any output, and then the second one I'm having print statements in there, even if it's not printing very much each time, it really slows it down. Just because of all the output buffering and so forth. So, let's see. I don't think I've had a situation where this actually comes up. But again, I don't really use a more command very often. Like if it's already have enough output to pause to stop the display. My hunch is that it would stop computation, but I can't really confirm that. This is one of the things that's awful about teaching is that when you're actually up for teaching, your IQ plunges by 50 points. So you might think about this after class, like, oh yeah, that. Okay, sorry. Okay, so that's the Gaussian elimination script where you see cases of nested loops. Now, oh, I've actually got to the last page of my notes. Yeah, because I took the rest of the tutorial and I divvied it up because I have today, Tuesday, next Tuesday, next Thursday to finish it, and so I got through all the pages I assigned for today, and it's only 7:39. I guess that's it then. So, yes. Oh, well, unless there are more questions, yeah.
Will you pull up the find max for just again this time?
Find max. Okay. Yes. And so these 5 files I've opened here, I will post. Yes. I'm sorry. I can't hear.
I couldn't access homework one. I'm just in
Okay. I'm.
homework one.
Homework 1 on Canvas.
Oh, which? Oh, the Canvas course.
This course
Okay.
on my canvas is not showing homework one.
Oh. Yeah, the homework is not posted there. It's on this site. Yes. Yeah, I only have the assignments there. Okay. Yeah. Other questions? Yeah. Yeah, but sorry. Oh. Yeah. Homework 1 is all the explorations in section 1.2. Yes.
How do you send it?
Oh, email. Yeah.
Email, it's like regular email now.
Right. Yeah, regular email. Other questions? Okay.